this similarity transformation. So what we have done, what I recollect, we have talked about the polynomial, right? So what we proved earlier, P inverse AP goes to the matrix, which is the diagonal matrix if the eigenvectors are orthogonal or linearly independent. Of course, for the distinct eigenvalues. If the eigenvalues are not distinct, they are repeated. In that case, what we see, it will be a Jordan matrix. So I wanted one kind of, say, AQ plus A square, say EA plus a Q is a polynomial, and I have given the matrix A equals to how much? Some 3 by 3 matrix I have given. Do you have that? 1, 2, 3, 0, 1, 2, 0, 0, 2. You can see the 2 eigenvalues are repeated and 1 eigenvalue is distinct. So if I want to find out the polynomial and A, P, Q, I think there are only 3 terms are there. And I asked some of you to give the answer. I think I'll be getting the answer maybe on this coming Friday, right? And how to verify the answer? You do the similarity transformation, get the answer. Put in MATLAB these things, A matrix. MATLAB will calculate A into A square and all, and you multiply them and get the answer. See the MATLAB answer, and your answer is matching. Okay? So that is the way we verify your answer. I am sure all of you know how to do MATLAB. There is a basic MATLAB calculation. And how to do that? So this is your f of A, right? This is the function of matrix A. And function of lambda will be m lambda q n lambda square p lambda plus q. Right? This is the function of lambda, which is the diagonal matrix. Okay? And what is this diagonal matrix? Which is lambda 1, lambda 2 up to lambda n 0, 0. If you have this square, you have to multiply with this, and definitely is quite obvious, which is lambda 1 square, lambda 2 square, lambda n square 0, 0. You can try to verify. It's very easy to verify. If you multiply this two, you get it, right? Correct? Yes or no? Yes. Okay. And similarly, we can get lambda to the power n, which is lambda 1 to the power n, lambda 2 and lambda n to the power n 0. Okay. So you can see that all these terms are easily evaluated for the diagonal matrix. For all these terms is evaluated. And what actually happens? There is a relationship between f and f lambda. What is that? Fa equals to, we have done last class, P f of lambda P inverse. And how this P matrix has been formed? We know that these are all eigenvectors. P inverse is easy if the eigenvectors are orthonormal. In that case, P inverse equals to P transpose. Okay? So if these eigenvectors are orthonormal, you can just directly interchange the row to column and you can get P inverse. So in that case, P inverse is very easy. You put it here P, this and this P inverse, and you can get the function of it. So that is the way we can easily evaluate. Otherwise, if this function is, if this is very, very complicated, say 8 to the power 5 and all those things, it will be very difficult. Even if you do by hand, it's very difficult. But with this similar transformation, it is pretty straightforward. Even sometimes MATLAB will actually hang. If you ask MATLAB to calculate 8 to the power 10, for example, MATLAB will hang actually. This matrix multiplication is a very expensive process. You will take a lot of time, but in your calculation, it will be very straightforward. And definitely same thing will be valid. So so now the second case is P inverse AP equals to the Jordan matrix, right? Okay, P inverse AP equals to Jordan matrix. Okay, so how to prove that? In a similar manner. You can go home and prove it. It is possible to prove that FA equals to P F of J P inverse. So for our problem, this is the method we have to put because our problem what will happen if you look at our matrix, they will have one generalized eigenvector and one independent eigenvector, and in that case the matrix is no more diagonal matrix. The matrix will be the Jordan canonical block matrix, and FA is nothing but P F J P inverse. How to prove it? Can anybody help me to prove? So FA, yes, can you please dictate to me? First step. FA equals to? Not MAQ. We have given the generalized part of your last class. We have the notes with you. A0, A0, A to the power n, or A to the power n, right? Am I correct? First term, and A1, A to the power n minus 1, and finally you get A0. Am I correct? A0 I. Identity matrix. And then what actually happens? A matrix is, so from here it is possible to prove P J P inverse equals to A matrix, right? P J P inverse equals to A matrix. So in place of A, we can, and it is possible to prove. That also has to prove it. We have done for the lambda matrix. It is possible to prove P J to the power n, P inverse is A to the power n. Right? It is possible to prove. How to prove? You have to do it the same manner what we have done in last class. The same manner what we have done in the last class. So, what will replace? You will replace A as P J to the power n, P inverse. A1 P J to the power n minus 1, P inverse. And it will go on. And A0 P inverse, right? A0 P inverse. So what actually happens? We can take out the P matrix from all the terms, okay? And we have AN J to the power n, A1 J to the power AN minus 1. Sorry, it should be n minus 1. Please correct it. N minus 1, n minus 1, J minus 1. It will be A0 I matrix, and it is famous. And it is nothing but, so this is valid for, so if you can write, you can actually have any P matrix such that this holds. If you can write in this way, it is possible to have this transformation, and you can have P matrix, it is A for J, and it is inverse. Okay? So this type of things are very, very important. If you see that when you deal with the higher matrices, when you talk about A square AQ, in your in chemical calculations, it may be possible to have A to the power n, right? Matrix A to the power n. Now you know how to calculate. You won't get side, okay, I have to calculate A to the power 5. No problem. Do the similar transformation, it will be just one step. It will be just in your hand. And that too, with the, and see, this matrix could be very, very complicated. I can give 1, 2, 3, 4, 5, 6, 7, 8, 9. One of the complicated matrix. You will be crying if I say, Evan will take you. But now you will be crying, you say, okay, I have the tools. And if you find the eigenvectors, the eigenvectors are still fine, no problem. P inverse, lambda, which is the eigenvector of the state, all lambdas will be automatically showing up. That's it. It will be a very clean operation. Right? So this is very common actually in chemical engineering may have. Do we have any example where matrix with higher order is coming? In chemical engineering? Say square into A to the power 4. Where is the chemical engineering example? Any such examples of that? Where is the example? Any examples there? maybe plywood process control, right? Definitely we will have something like it. We try process control and just you can see that. So process control, you can see that all those kind of things may arrive and you have to be dealing with higher order matrices. And so now we can actually, so the point is, now I am going to discuss how to calculate J square, because J square now we will see that it is not that easy because we have off diagonal terms will be there. It is not that straightforward. So if you want to know about what is how to calculate J square, we have to little bit wait, and then I will first discuss the generalized solution of dSdt equals to Ax in the format of lambda and j. Although I have discussed, but I will just summarize before getting into the j square. dSdt equals to Ax is a typical problem, and we have the initial condition x bar t equals to 0, which is x0, right? And if distinct eigenvalues we can get dy dt equals to lambda. Okay, and what we get, y bar t equals to, what's the generalized solution from here? We have done already. What's the generalized solution? Pardon? E to the power lambda t c, and c we have already found out from the initial condition. What is that? Y naught bar, not y naught bar, which is the vector. And for the repeated eigenvalues, in case of generalized eigenvectors, we have dy dt equals to jy. How to prove it? dSdt equals to x to j dy dt jy. Same thing. You have to just multiply, and you can actually know that p inverse f equals to j. In that case, we can do it, and we have y bar t e to the power j e y 0. Both the things are actually well. Okay. And lambda and j, we can say lambda is a diagonal matrix. J is not, because j has a super diagonal, and super diagonal terms will have only one other term should be 0, but super diagonal is the top of the diagonal term, it will be a non-zero term. So this entire thing we can write as yt is the L matrix y0. L matrix is e to the power lambda. So what we can do next, how to get x? We have done so many times. How to get x from here? How to get x? How to get x? See the situation. I don't know whom I am teaching actually in the class. What is that? X equals to p, huh? I am not able to hear what you are murmuring. I am not able to hear. P y is x, so I have to multiply by p, right? If you multiply by p, yt, which is nothing but p l, then we can actually write p inverse y 0. Okay, so this is xt, and what actually happens? So you can write p inverse py 0 here, whatever way. So py 0 is nothing but x0, pl p inverse x0. So x0 is the initial condition given here. X2 you have desired solution. So p is the matrix, and p inverse the matrix obtained from the eigenvectors. L matrix is either, so L could be either e to the power lambda t or e to the power j. So that's a generalized formulation. It is very clear cut. It is very clear cut formulation. The distinct now for any system, if you have been given any chemical engineering system, you know either it will fall this category or this category. This is the worst category. You cannot have anything else worse than this. And of course, your solution is given. Your solution is xt, pl, p inverse. L here is e to the power jt for the generalized eigenvector, and for the distinct eigenvectors, it is e to the power lambda t. Right? And how to calculate e to the power lambda t? I will now do it here. It will call lambda t equal j t. So it will lambda t is nothing but I lambda t lambda square by 2 factorial t square. You can say t cube by 3 factorial lambda cube and so on. Lambdas to lambda cube I have already shown. Okay. So what actually happens? This is 1 0 0 0 1 0 0 0 1. This is lambda 1t lambda 2t lambda nt or lambda 3t. I am just saying 3 by 3 matrix. 3 by 3 matrix. Okay. So you can say let lambda be 3 by 3 matrix. This is 0 0. Next term will be lambda square t square lambda 2 square t square by 2 factorial lambda 3 square by t square 2 factorial 0 0. It will go. So if you look at the first term, if you add it 1 plus lambda 1t lambda 1 square t square by 2 factorial will go 1 into the power lambda 1 the series. All other terms will be 0 because corresponding terms will be all 0. Similarly, corresponding terms are all 0 here, and first term is 1, then lambda plus lambda 2t plus lambda 2 square t square by 2 factorial and so on. It is e to the power lambda 2t 0. Similarly, these terms are 0 e to the power lambda 3t. So that is the way one can actually. Similarly, this can be extended for a generalized matrix. For a generalized matrix, e to the power lambda t will be e to the power lambda 1t, e to the power lambda 2t, e to the power lambda nt 0 0. Situation is not that straightforward for e to the power j. Let's look at e to the power j. So if you look at here, either you have L matrix e to the power lambda t or e to the power j. Let's look at e to the power j. See, e to the power j, I am considering j. Consider j as 3 by 3 matrix. Consider j as 3 by 3 matrix. And j matrix, I will be having one of the worst kind of matrix, which is lambda, 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 1, 0, 1, 0, 0. We can see that it has one eigenvector and two generalized eigenvectors. The j matrix. Now, I want to find out e to the power j. So this j can be decomposed as lambda, 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 0, 0, and this is as 0, 1, 0, 0, 0, 1, 0, 0, 0. And I say this matrix as J1 matrix, this matrix as J2 matrix. This matrix as first is J1 matrix, first is J, second is J2. Remember that this process actually I worked on. I didn't find this kind of process in any of the books. When I was doing teaching assistantship during my PhD time, this kind of course was offered in IISc Bangalore, and I was the teaching assistant, and that time I devised the method. So long back, so almost like 20 years back, I devised this method, and I found this method is most of the time very powerful. So, but you won't find this type of techniques in any of the books. I found this a very effective technique. I wanted to teach so that you can actually get much better approach. Remember that we have to find out e to the power j. So e to the power j, it is nothing but e to the power j1t e to the power j2t. Is it correct always? I am peacefully claiming that. Why I am saying that? Because we can write e to the power j1 plus j2t Okay? And you are writing this. Is it correct or not? That's what I am asking. See, for the scalar quantity, that is pakka. We know that it is correct. But for the matrices, is it correct or not? Pardon? Pardon? No, that's there. That has to be there. That has to be there. Otherwise, you cannot construct J matrix. They are of same order. That is the basic not assumption, basic fact. Otherwise, J calculation will not be there.
J1, J2 should be equal to J2.
Wow, excellent answer. That is, they have to commute. That is called they have to commute. Why? If you look at J1 plus J2t, which is I plus J1 plus J2t plus J1 plus J2 whole square, t square by 2 factorial and so on. Okay, so next step will be J1t plus J2t, J1 square plus 2J1, J2 plus J2 square, t square by 2 factorial and so on. J1 square, J2 square, okay. Okay. Only problem is J1, J2. Remember that for any matrix AB not necessarily equals to A, which is commutative property. They don't commute generally. For some cases they commute. If they don't commute, you cannot write AB equals to A. Right? So what actually happens? In the left hand side. Right hand side, we have e to the power J1t, e to the power J2t. J1t we can write I plus J1t plus J1 square, t square by 2 factorial and so many terms. Similarly, you can write I plus J2t plus J2 square, t square by 2 factorial plus so many terms. Now, what actually happens? This I and I, if you multiply to of course I, then J1 J2t square, J1 J2 t square, and then J1 J2 square is coming. Similarly, what will actually happens? What actually happens? So J1 square, J2. So if you because in this way we can also write this as e to the power J2t and e to the power J1t. This is both the same. So in that case, what actually will happen that you may get J2 J1 also. Okay. So when you decompose, there's a chance to have J2 J1 or J1 because if you do that, if you do this way, what will actually happen? J2t, J2 square, J1t. I can also write that. This is mathematically valid. No question. So in that case, because any matrix A plus B, we can write B plus A. They come. No problem. So you can write J1 plus J2 or J2 plus J1. If you write J2 plus J1, you will J2 J1. In that case, what will actually happen? You will have J2 J1, right? Okay. And we also have, if you look at this, we have the J2 J1 and 2 and 2 are coming. So this term is particularly appearing here. That's not a question. If you see the particular term, 2 by 2 cancel, and you are getting, so you are getting J1 J2 from here. Right? You are getting J1 plus J2 from here, and you are getting J2 J1. That means this decomposition is valid if J1 J2 must be equals to J2 J1. What are other things actually happening? If you look at other higher order term will be coming, J1 plus J2 whole cube, so it will be J1 J2 square should be equals to J2 square, J1 also should be valid. So all the multiplications, whatever actually are appearing in this overall phenomena here, they have to commute. If they don't commute, this method what I devised will fail. The method what I devised will fail. This decomposition will not work. If the multiplications involved in e to the power j1t, e to the power j2t, or multiplication of the matrices are not commuting. Do you have any questions here? Because if you don't ask questions, things later on you won't be able to understand whatever I am going to teach. So, no questions. I hope everybody is understanding fine. But I am telling you that 90% of the class didn't understand. And you are not asking questions, you are thinking that you understood everything. Any question? Again I am asking. Any doubts? Okay, so let's look at our current matrix. So when this matrix will be constructed, we have to see first this is valid or not before starting the calculation. Before starting the calculation, you have to first see whether they are commuting or not. So left hand side, which is lambda 0 0, 0 lambda 0, 0 0 lambda, and we have 0 1 0, 0 0 1, 0 0 0. What are you getting? Quickly give me the answer. This is very easy multiplication. Very easy multiplication. What? 0 lambda 0, 0 0 lambda, 0 0. Okay. What will happen right hand side? What will happen right hand side? Right hand side will be 0 lambda 0 0. Another thing is that when I did this term, what is the way? I have skipped the steps. When I evaluate this method, what is the way to evaluate this j1 plus j2 square? Is it simple a plus b whole square, a square plus 2b plus b square, or something else? I skip some of the steps because I assume they commute. No. General step is if they don't commute, you have to write this way: j1 square plus j1 j2 plus j2 j1 plus j2 square. These terms are okay, but if they don't commute, you cannot write it j1 j2. I assume they are commuting. If they don't commute, here itself you have a problem. If they don't commute, here itself you have a problem. Okay? If they don't commute, here itself you have a problem. So you have j2 j1 and j1 j2. So before starting, so this method, so what I actually devised, this method has limitation. If j1 j2 is not equal to j1, at least in that case you don't have to verify the higher order term. If it fails, there is no point to verify the higher order term because the method fails. Because the method fails, in that case it will be very difficult to calculate. Because if you cannot decompose, it will be impossible to calculate what j2. It will be impossible to calculate the j2 because of the off-diagonal term of the j matrix. It is not I cannot write j square equal to lambda square, lambda square, lambda square, 1 1. I cannot write it. If it is 0, then I can write j cube equals to lambda cube, lambda cube, lambda cube, 0 0. But if it is 1 1, that is not that simple. That's what to decompose. So that this part will be okay, this part can be separate. Okay? This one is here. So this part is very important. If j1 j2 won't commute. So basically, if I give any kind of matrix operation, you cannot assume any of the formula. You have to go to the very fundamental level and try to see, because this cross multiplication term will be there, and that will be separate serious problem. So let's talk about so far we have talked about the homogeneous system. Now we'll be talking about the non-homogeneous system of differential equation. How to apply the similarity transformation for the non-homogeneous system. I guess everything is clear here. We'll be coming back how to evaluate. I will take up one example problem and where we'll show how to do the evaluation stuff. So we have dx dt equals to ax plus b, non-homogeneous term, right? And I want to solve this by the similarity transformation. What will be my next step? I want to solve, now you know the technique. What will be my next step? What will be my next step? What will be my next step? By similarity transformation, remember that. By similarity transformation. By similarity transformation, how to do it? By similarity transformation. By similarity transformation, how to do it? How to do it? That's what I'm saying. I am not seeing any kind of enthusiasm in the class. How could we get dy dt? Yeah, see, you are not saying that. If I say like this in the class, you will be happy with. What is the next step? Pardon? Next step is multiply by p. Multiply by p. The simple step. That fundamental things I am not getting from any of you guys. So p inverse dx dt equals to p inverse a. What is the next step? P inverse a. P inverse plus is p meeting? Is that correct? Correct, huh? He said correct. That means you are blindly copying from the board. I got you. People are nodding the head. I am telling you, you should be first attending the kindergarten class, then come to the MPhil class. I think we need kindergarten mathematics. Simply people are copying. I was deliberately doing mistake also. When I was saying p, multiply by p, you all said p. I am just seeing what kind of level we are having actually. This fantastic level. Next step. dy by dt, dy bar by dt equals to lambda, this will be y bar plus, we will assume this as g vector, ge for the distinct eigenvalues, or it will be jy for the generalized eigenvectors. This first one is linearly dependent eigenvector, and second one is for the generalized eigenvector. Okay. So what will happen next? We have done this type of problem earlier. How to solve it? We have done it earlier. What's the next step? What we have to find out now at this point? Why are we have to find it? But there is something I need to evaluate before that. Anybody just raise the hand. It is not a fish market. What we have to evaluate for this? We have done it already, this kind of problem. What is the even G? What kind of thing you are talking about? What you have to evaluate now before solving it? You have to multiply the system, right, with something. What is that? Nobody reads my note. I actually feeling very much frustrated. I feel like leaving the class. Frankly speaking, it was not like that in the last batch. I don't know why so much of negligence for the mathematics course. Some people are arbitrarily sitting actually. I can see that. That's no problem. At least 1 or 2 answers I am getting. Basudha, no answer from you? You don't know anything? How to solve it? If it is scalar system, how to solve it? If I have a system say dy dx equals to say lambda y plus b, how to solve it? How to solve it? This is the level I am going to. How to solve it? So why not tell that the same thing? I have done it, right? For this kind of system integrating factor, please go back to the class notes. Please. Do you have the class note first bench? Yeah, please go back now. I am not a barking dog in the class. Do you have the class notes here? Yes. Yeah, why not? Do you understand my English? Yeah. If you please understand my English, so please, sir, I am requesting you how to do it. This is too much ridiculous actually. Now I have to, in an MTech mathematics class, and I have to go to this level. What's the next step? I have done it. You follow my class in case pattern. What alpha? Where is any alpha is there? What are talking alpha? Have you understood? I remember that last year I have not done the every step. This year I have done every step. Even my senior MTech student told me, sir, you are doing every step. And I don't know what's the use of that. I have done that. It is every step. And I don't know what's the use. I'm really frustrated in the class. Integrating factor is what? I know how to. IF is what? What is IF? E to the power? Just one hand please. One hand, one answer. One hand, one answer. Who will give the answer? Nobody wants to give any answer? E to the power minus lambda t. Okay, next step. Next step. Next step is what? What we have to do next step? What y into? I want more fundamental. What do we do generally? Multiply. Why you are not saying that? I don't skip the steps in the class when I teach. You are skipping. The next step is e to the power minus lambda t dy dt. Then side change minus e to the power minus lambda t. We have lambda y. And we have e to the power minus lambda t g t. Right? What is the next step? What's the next step we have done in the class? What's the next step? It's taking so much of time. I'm really surprised whom I'm teaching in the class. Yes? ddt of e to the power into y. Yes, equals to e to the power minus lambda t gt. Next step. This lambda will be replaced by j if it is if you are having generalized eigenvector. Next step. We have done the next step. Yt equals to. We have done it. Please go back to class to get the answer. What will be? Y bar t equals right hand side. I want the final answer. We have done it. I have done in the class. In terms of constant, you can give. In terms of constant, you can give the answer. What is the first term? What is the first term? Right hand side, first term. Directly it will be coming, first term. I am asking yt. It is if ddt is there. I am asking yt. What will be the term here? What will be that? Integral. See, I have to push like this to get the answer. It is very difficult. 0 to what? T. So next step. E to the power minus lambda. Are you sure? You are putting 0 t limit. Lambda. Directly you are saying, that means you are guessing. Now you are actually I am having a lottery show in the class. People are guessing different kind of answer. I have to say yes. I am doing lottery show in the class. I feel like not to cover much in this batch. Why to cover? T minus tau you are saying. Another answer I got T minus tau. What is the correct answer? Entire class is actually quite, many guys are doing some other activities, I know that. Many guys are doing some other activities. What is the answer? I am very surprised. This thing I have done in the class, that's the thing. I am so frustrated. Last batch I have not taught this way. This batch I took so much care and I am getting the prize also. me. Even I am asking you to go to the class to get me the answer. That also you cannot get. What a level of yours. All people are actually browsing. They don't even know where the things are written. The people don't even know actually. I am seeing people are browsing through. What's the answer? What's the answer? Vasudha, you are also lost. I thought you were a good student. I was thinking that this answer also you cannot give. It was taught in the class. G minus tau. Then next term. Next term. G vector of tau. Next term. Next term. Not lambda tau. It is t means it has to be t only, right? Into 1. Why not? How why not? C. Okay. So if you want to put directly, why not? You can do that. I thought I have to put one more step. Right? If you don't want one more step, fine. So same way for the J matrix we have y bar t, which is 0 to t e to the power j t minus tau g tau d tau e to the power j e y 0. So how to get xt from here? How to get xt from here? How to get xt? So you will multiply by P matrix. So we will get 0 to t P matrix e to the power j t minus tau g tau d tau plus P e to the power j t P inverse x 0. Am I correct? Because there is a relationship, so P inverse, if you just do that, P inverse y 0 will be becoming x 0. That we know that. And we will be having, we will be left with P e to the power j t P inverse. So that is the way xt has been calculated. Now I will give one example problem, which covers everything. So with that I will actually finish in a transformation. Next we will starting with what TA. So dx dt equals to ax plus bt. A matrix is 1 1 1 2 1 minus 1 minus 3 2 4, and B vector is t 1 1 and its initial condition x bar t equal to 0 1 0 0. So A matrix 1 1 1 2 1 minus 1 minus 3 to 4. B vector is t 1 1 and U vector is 1. X vector is at t equal to 0 is 1 0 0. What are the eigenvalues? Okay, so I will be solving this based on the technique what I discussed. So this entire problem, if we solve, we know how to apply similar transformation for a very generalized system where we have generalized eigenvalues. Okay, so what are the eigenvalues? What are the eigenvalues? What are the eigenvalues? What are the eigenvalues? I'm really getting shocked, getting eigenvalue, you are really struggling quite a lot. Many guys don't even have calculator. Somebody is actually putting calculator in the bag also. If you use the calculator, you can get the answer very quickly. Any answer for the eigenvalues? much you got? Third bench. Eigenvalue. What is that? What are the eigenvalues? 3, 1 and 2. My God. I have not given easy problem. 3, 1 and 2 is very easy problem. Minus 0.35. My God. I think your brain is not working today. Some problem. Yes, madam. You are getting 4. It's like a gambling show. I'm actually having gambling. She got 4, one person got 3, 1, 2. One got even minus 0.35. Anybody wants to do any gambling with me? Yes, sir. Oh, 10.10. It's a very good gambling. But you're not getting any money out of that. So his gambling number is 10. Any other gambling numbers? Yes, madam. 4.1. Let me check. 1, 1, 1, 2, minus 2, 1, minus 1, minus 3, 2. I have given the correct matrix. 4.6, not a correct answer. Not a correct answer. Not a correct answer. Eigenvalues, I am very surprised that 3 by 3 matrix I have given. So for 10 people get the answer, all are wrong. My God, it's a wrong answer. Pardon? Do you know how to find determinant? If you are not sure how to find determinant of the formula also, one-step formula. One-step formula is there. With that step, one-step formula you can find out. You got 2, 2, 2. Can you show me the calculation? Come here. How I want to see how you got 2, 2, 2. Right answer is 2, 2, 2. All are same. Only one person so far, 1 or 2 people got in the entire class. I really must congratulate you. You really struggled so much to find the eigenvalues. So I don't know how much you will get in your first quiz. So lambda equals to 2, 2, 2, and it shows that it is a non-symmetric matrix, and that means you will get generalized eigenvectors. No doubt about it. So you have to find out one eigenvector from the non-space basis, and other eigenvectors will be calculated from the generalized eigenvector relationship. So that's it for the today's class. And next class, Friday, we'll be solving this problem and going the further topics. Next question. Attendance.